Now, there's always been a big debate in the gas industry on which heat exchanger for boilers is best. Is it copper? Is it cast iron? Is it stainless steel? Or is it aluminium? Well, my name is Derek from Tomcat Gas Training, and in this video that's exactly what we're going to find out. What is the best heat exchanger for a boiler? So, let's get on with it. Now, some of you might even be asking, what is a heat exchanger? Well, the purpose of a heat exchanger is to transfer heat from one source to another, hence the name, heat exchanger. In the case of a central heating boiler, this means transferring the heat from the POCs, the products of combustion, or the flue gases, into the water. And then this hot water will be circulated around the home to the radiators, to underfloor heating, and to hot water cylinders. So, how does this boiler actually do it then? Well, basically what it does is the gas comes into the boiler via the gas valve into the burner. The burner then ignites the gas via an ignition source, and then these hot products of combustion then rise through a heat exchanger. The heat then is transferred via the heat exchanger into the water, and then, like I say, this water then is transferred through the pipe system to the radiators, to underfloor heating, and to hot water cylinders. Now, new condensing boilers are slightly different in that process, where the gas is forced in either horizontally or downwards to gain more heat out of the gas. Now, in an old boiler, the products of combustion exiting the boiler could be around 150, 160 degrees centigrade. So we've wasted all that heat. But in a new condensing boiler, the flue gases exiting the boiler could be lower than 50 degrees. So we've taken out a lot of the latent heat from the products of combustion. So that's what makes them more efficient. So, in a nutshell, we begin with gas and cold water, and we end up with hot water and warm flue gases going out to atmosphere, and the hot water going off to the radiators and the cylinder. The process is as simple as that. Or might not be simple, but anyway, it is. Now let's have a closer look at these heat exchangers, and let's start off at the beginning and look at cast iron heat exchangers first. Now, this Potterton Kingfisher 2 floor standing open flued boiler has a cast iron heat exchanger, which is just located here. Now, cast iron heat exchangers are composed of iron, carbon, silicon, and may contain traces of other elements. Now, traditionally, cast iron heat exchangers dominated the UK market for decades, and you may still find homes and businesses in the UK where they're heating their premises and water by boilers using cast iron heat exchangers. There shouldn't be. Now, in my opinion, there should be no boiler in the UK with a cast iron heat exchanger, because they're just not efficient enough for our modern living. Now, originally we used cast iron heat exchangers because of how robust it is. It doesn't break very easy. And they also originally used it because it had tolerance to sulfurous flue gases, which is a byproduct of burning coal. So when these things first came out, we weren't on natural gas, we were on coal gas, or Towns gas. And the reason why some of these are still around today is because of how robust they are, and because they have large waterways, so they don't block up very easily. But if you do have one of these and it sings like a kettle, then it is getting blocked up with limescale. And like I say, we should be having these in today's society. Now, the reason why we don't have cast iron heat exchangers today is because of condensing boilers. And cast iron isn't very good for condensing, because when boilers condense, the water they produce, that's why they're called condensing boilers, because the byproducts of burning natural gas is carbon dioxide and water vapour. And what the boiler is doing is it reduces the flue temperature that much that those water vapours turn back into water and condense, and then that's why we call them condensing boilers. But that water is very acidic, and cast iron heat exchangers don't like acidic water, so they would rot very easily. So because of all this, these cast iron heat exchangers don't meet all the energy saving things we need to do now for Part L of the building regs and stuff. So that's why manufacturers don't use cast iron heat exchangers. Well, I'm saying manufacturers don't use cast iron heat exchangers, but you may still find some out there on condensing boilers where they use a secondary heat exchanger made of stainless steel. So there are some oil boilers out there and some commercial boilers which the heat exchanger is still cast iron, but they have a secondary heat exchanger which takes more heat out of the products of the gas, which then condense. But because stainless steel is pervious to the acidic water, then we get away with it that way. So in a nutshell, that's cast iron heat exchangers. Heat exchangers which shouldn't be around today, but for some reason people still love them. Now, after the cast iron heat exchanger, we went to this type of heat exchanger. So this is a copper heat exchanger. I know it's silver, it's coated in a special coating, but this actually is all copper. Now, it is said that the thermal conductivity of copper is 20 times greater than stainless steel. So why aren't we using copper now as heat exchangers if they're that good? Well, again, like cast iron heat exchangers, copper isn't very good with products of combustion that are acidic. It still rots them. Now, the boiler we've got here is a heat line band B condensing boiler. It has the same main heat exchanger as this one. So why are we still calling it a condensing boiler if it's got a copper heat exchanger? And I've just told you it rots. Well, we have this heat exchanger here, which is a secondary one, pretty much like I explained with the cast iron heat exchanger, where they're using a stainless steel secondary heat exchanger to take out more heat from the flue gases. And this is exactly what this Band B boiler did. So when condensing boilers came out back in 2005, they needed a way of using up all the old boilers, so they came up with this idea of the Band B boiler. Didn't last very long, only about 2 or 3 years, and then we just went solely to Band A boilers, which we're at now. So how does this heat exchanger work? So basically this is our burner here. The flue gases go up, the water passes through here. You can kind of see the waterways here. So the water passes through, heat exchangers like that, the flue gases come up, they come into the hood here, the fan then pushes the flue gases through a secondary heat exchanger, which is made of stainless steel, which is where the condensing process happens. So the return pipe comes into here before it comes back into this copper heat exchanger. So that's how the Band B condensing boiler worked, which there's still quite a few of them out there today. So that's copper. Fantastic at heat transfer, but not very good in the condensing process. Now let's talk about aluminium heat exchangers. Now the two boilers we can see here, this is an Ideal boiler and this is a Worcester boiler, both have aluminium heat exchangers. Now most of the boiler manufacturers do have a range of aluminium heat exchangers. Some just only have aluminium, some have aluminium and stainless steel heat exchangers. It depends on the manufacturer. Now the way this heat exchanger works, now this one has a stainless steel outer but actually is an aluminium heat exchanger, this Worcester. So what happens is the gas comes into the gas valve, the fan then sucks the gas out, mixes it with air, sends it and blends it into this tube, which then comes into a burner, which then forces the products of combustion, the POCs, down through the heat exchanger, which takes out all that heat, which then turns it into carbon dioxide and water vapour. But because we've got because it is a condensing boiler, the condensate then collects in the sump, which then goes down into the trap. The product combustion then come up and then out through the flue system. So that's basically the process of these working. Pretty much the same as this ideal here. Now these aluminium heat exchangers are very, very light compared to cast iron and stainless steel heat exchangers. So that's why they are commonly used. They also can be cheaper, not all the time, but they can be cheaper than stainless steel. So again, that's why a lot of manufacturers use them. But the main reason for manufacturers using them is their thermal conductivity. And it is said an aluminium heat exchanger's thermal conductivity is 4.5 times better than a stainless steel one. So that's why a lot of the major manufacturers use aluminium. But one of the major downsides of an aluminium heat exchanger is galvanic corrosion. And the pH levels in the water must be kept perfect. Otherwise, these heat exchangers start to pinhole and corrode. So that's one of the major downsides of them, but we'll talk about pH in a minute. Now this is an ideal heat exchanger, aluminium heat exchanger, and you can just start to see here water coming through the heat exchanger where it's corroded. If you look very closely, you can just see the water on the edge and where it's starting to pit and corrode here. Now, like all heat exchangers, aluminium heat exchangers have pros and cons. Now, the pro for an aluminium heat exchanger is they have small waterways. So these small waterways allow the heat exchanger to take a lot of heat out of the products of combustion incredibly quickly. But the con for that is they block up incredibly easily and quickly. So this is one of the major reasons why now the regulations are changing, that when boilers are installed, they must be installed with a magnetic filter and the water quality must be checked and kept up to date. It's important that the pH levels in the water, like we talked about before, needs to be kept perfect for aluminium heat exchangers. And these magnetic filters take out the magnetite to stop these small waterways from getting blocked up. But like I say, these major pluses for these heat exchangers are they're a lot lighter, they can be cheaper in some cases, and they heat up incredibly quickly. Now let's quickly look at the pH scale for the central heating water. So in order to minimise the corrosion of the boiler hardware, the pH in the feed water, or the central heating water, must be controlled within a narrow range. Too low the pH will result in excessive corrosion of the iron components, while a too high pH will result in attack on the copper containing parts. Now the aluminium heat exchangers must be kept between 6.5 and 8.5 on the scale, but stainless steel heat exchangers have a far bigger range on the pH scale than aluminium and copper. For this reason alone, stainless steel heat exchangers are far more robust than the aluminium or copper heat exchangers. So, that's aluminium heat exchangers. Let's now have a look at stainless steel ones. The two boilers we have here both have stainless steel heat exchangers. And stainless steel heat exchangers over the years, they've kind of made a progression. Now when these first came out, especially this one, it had 10 millicoils of stainless steel and 2 passes. And that's kind of changed now with a lot of the manufacturers. I'll pick this one up because it's heavy. I've gone to this system where it's kind of a 28mm piece of pipe squashed and one continuous piece. So that's the kind of progression a stainless steel heat exchangers had over the last few years, because of, like we were saying before, about the waterways being contaminated, pH levels not being kept at the correct levels, and this magnetite flowing around the system and blocking up these 10mm pipes within these heat exchangers. Now stainless steel is actually an alloy made up of iron and chromium. I think that's how you say it anyway. And there has to be about 10.5% chromium in with the iron to make it corrosion resistant compared to the cast iron heat exchangers. Because as I've said before, cast iron heat exchangers corrosive resistance, and it is stainless steel at the end of the day. It's got steel in it. And it must also be understood that the performance of the stainless steel is dependent on the amount of coronium, I hope that's how you say it, is actually in the metal. So basically, in a nutshell, that means if the stainless steel isn't of a very high grade, about 316 stainless steel they say, then it's not very good for a heat exchanger. Now there are many different types of stainless steel used in heat exchangers, and some manufacturers actually weld their stainless steel and some actually don't, to make it less likely to block up with magnetite. So like I say, 316 stainless steel is the main stainless steel used for heat exchangers because of its weldability and its resistance to corrosion. Now compared to aluminium, stainless steel has a larger band for the pH level. Now basically a stainless steel heat exchanger doesn't need inhibitor in it, but because we've got copper and steel in the system along with the stainless steel, then we will need to put inhibitor into the system. Aluminium will always need inhibitor putting in because of the galvanic corrosion. So that's another thing where if we had everything stainless steel pipes, stainless steel radiators, stainless steel fittings and stainless steel heat exchangers, then we wouldn't need to put inhibitor into our system. Because we haven't got that, then we need to make sure we still monitor our levels of pH in the water, and we still need to fit a magnetic filter even on a stainless steel heat exchanger. While an aluminium heat exchanger is a lot lighter than these stainless steel ones, and kind of a lot cheaper to manufacture, the properties for the stainless steel is far superior to that of the aluminium heat exchanger, and is less likely to corrode than the aluminium one if your pH levels aren't perfect like they should be. So stainless steel is known to be one of the most durable and strongest metals we have on our planet. So that's another good reason why manufacturers use stainless steel for a heat exchanger. Stainless steel can also handle a lot higher temperatures than the aluminium one, so a lot of the LPG boilers for the manufacturers, they like to use stainless steel because of its a lot higher temperature for its combustion. So that's stainless steel heat exchangers. Shall we sum up then? So far in this video what you've found out is most of the heat exchangers have pros and cons with them. And they have advantages and disadvantages. But the suitability of a heat exchanger on a project will depend on quite a few factors. So, is the job a new build, or are you retrofitting a new boiler to an old system? What type of building are you installing this boiler in? Is it a town hall, a church, a school, or a domestic dwelling? What is the heat load for the job? And what are the environmental objectives of the job? It can be crucial to look at the nitrogen oxide levels produced by the boiler when you're working in inner city areas. How's this boiler going to be looked after? Is it going to have a planned maintenance scheme with it? Is it going to be checked every year? Because most domestic properties don't have their boiler serviced. What are the warranties for the heat exchanger and the boiler, and who's going to control the pH levels? And finally, the cost factor. Most domestic customers don't really care about whether they're using a stainless steel, aluminium heat exchanger or not. They just care about how much is it going to cost. So they're all the things what need to be taken into consideration when you're actually purchasing a boiler with a certain type of heat exchanger. So basically, in a nutshell, as we found out, is a stainless steel heat exchanger is far more durable with larger waterways, but it is quite heavy and more expensive. And an aluminium heat exchanger has smaller waterways, is cheaper to manufacture mainly, and heats up the water a lot quicker than stainless steel. Now again, stainless steel, we don't really need to worry about inhibitor levels for the heat exchanger itself, but we do for the system. But with an aluminium heat exchanger, we need to make sure we keep on top of our pH levels. Also, if we don't keep on top of lime scale, if you're in a hard water area and sludge, magnetite, no matter what heat exchanger is installed in a boiler or what boiler you install, it won't make any difference because it won't last very long. Also, if boilers aren't serviced every 12 months and pH levels aren't monitored and magnetic filters aren't cleaned, then again, how can you expect a boiler to last very long? A lot of boilers now come with very, very high warranties, 10, 12 years. Most of them at least give you 5 years. So if you don't look after the boiler, you don't look after the heat exchanger, then it doesn't really matter which heat exchanger is installed in a boiler. You might as well just go for the cheapest one you can find and chuck it away after 5 years. So, if you're looking for my opinion on heat exchangers, I've always preferred the stainless steel heat exchanger. I've always found that boilers with stainless steel heat exchangers seem to have less failure rate on their heat exchangers themselves than aluminium ones. That's just my opinion, and I will always buy a boiler with a stainless steel heat exchanger for my properties. So, that's my look on heat exchangers and which is the best one. My opinion is stainless steel. What's yours? Put it in the comments down below if you prefer aluminium over stainless steel. But if you have liked this video, why don't you give me that thumbs up or leave a constructive comment down below. If you've not subscribed to my channel, then please subscribe because it helps. And don't forget to hit that notification bell because you want YouTube to tell you when I'm uploading videos. Seems to be Sundays and Mondays and anyway, seems to be loads of different days. So all I've got left to say is thanks for listening, thanks for watching, hope this video's been some help, and I'll catch you on the next one, guys. Cheers!